Okay, here we go again. This is our second assignment dealing with hypothesis testing with probabilities. So again, we're not talking about averages, we're talking about probabilities. If you want a little bit better of a video kind of explaining the initial process, take a look at the previous video of assignment E, assignment 9E. Would probably be a little bit better. This one I'm going to kind of pick up the pace just a little bit. And again, I'm going to try to explain myself, but I'm going to pick up the pace just a little bit. So women athlete at University of Colorado Boulder has a long-term graduation rate of 67%, okay? Over the past several years, a random sample of 38 women athletes at the school showed that 21 eventually graduated. Does this indicate that the population proportion of women athletes who graduate from the University of Colorado Boulder is now less than 67%? Use a 5% level of significance. Okay, so the big probability, the probability that we accept is 67%. Okay, we need to get a big Q, which again is 1 minus P, and so that would be 33%. From there, we see that we took a sample of 38 women, and the graduation was 21 of that 38. So my sample probability, which is, again, R divided by N, is 21 divided by 38. 0.5526. We want a 5% level of significance, and the question that is being asked, is it now less than 67%, question mark? So our null hypothesis is what the probability is accepted as historically true. So historically it says that it's 67%. Now, what are we trying to say about that 67%? Is it bigger? Is it smaller? Is it not equal to? And we want to see, is it less than 67%? That's what the question is asking. Is it less than 67%? Our level of significance is alpha, and in this case, that is 5%. And I see that my inequality is pointing to the left. This is a left tail. So the rejection zone will be on the left-hand side of the curve. And I'll get a negative z-score. Okay, because this is a probability, probabilities lead to z's. So this is going to be a standard normal. All right, z with probability is going to be p hat minus p divided by regular p, regular q divided by n, and that is in a square root. Where you want your parentheses is at the beginning and right here. That's where you want your parentheses. So I take my p hat minus the p divided by the square root of p times q divided by n. Close. Make sure you close all parentheses. So that, again, this is a z-score, so we round to 2 decimal places, so that's going to be 1.54. Here they want me to get my p-value and then make a sketch. So the p-value is based upon the answer that I just got, and my previous answer is z is negative 154. I would always look this up as a negative. It's already a negative, so I don't have to, don't think of it as like a positive, but it's still just negative 154. Okay, so negative 154, negative 154, 0618. Okay, that is my p-value. So I put this on the table. This is a left left tail, so the rejection goes on the left. And that is alpha, and alpha in this situation is 5%. Taking a look at my p-value is 0.0618. 0.06 is bigger than 0.05, so its distance from the edge will be larger, and so my p-value falls up here, bigger than. And so its distance from the edge is larger than the alpha. Okay, so that makes it all the way to the do not reject H naught zone. So that's what I'm going to say right here. So I notice that my p-value is larger than my alpha. That means do not reject H naught. That means we do not have enough evidence to say H1. We do not have enough evidence to say H1. H1 is saying P is less than 67%. That's what H1 says. Yeah. So we do not have enough evidence to say the probability of female athlete graduation of I'll say a woman athlete graduating. Okay, that's the probability. So the probability is less than 67%. Don't get lost in the words. I do want you to attempt the words, but really, really, really the important pieces of this answer is that you say the words probability is less than 67%. Yes, I do want you to make an attempt at putting the correct context, but again, what I'm really grading it off of is, do you literally use the word probability, not the word proportion, but you have the word probability. I see the words is less than, again, with the word is, okay, not smaller than, not is, not as good as or something like that. It is less than, and then 67%. That's really kind of what I'm grading this off of, and then leading up to this part. But so we do not have enough evidence to say probability is less than 67%. That's kind of like what I do a quick scan when I'm grading hundreds of papers at a time. I'm looking for these words. If you have these words, you're probably good to go. If you don't have these words, you're probably going to get marked wrong. Okay, another probability problem. So U.S. Department of Transportation, National Highway Traffic Safety Administration reported that 77% of all fatal injured automobile drivers were intoxicated, so fatally injured. So the probability of dying due to of injured drivers, fatal injured drivers, 77% is due to intoxication, so that's 0.77. That would make Q, which is 1 minus P, 0.23. All right, so we take a sample, a random sample of 27 records of automobile fatalities in Kit Carson, County, Colorado, showed that 15 were intoxicated drivers. So a sample size of 27 showed that intoxicated deaths due to alcohol were 15. So R divided by N says the probability of our sample is 55. So 5556. Okay. We want a level of significance to be 1%, and we want to see, is it now less than 77%? Because they're saying that it's 77%. Our sample is saying that it's 55%. So what we're trying to say is our evidence strong enough to say that it is less than 77%? We can't say that it's 55%, but we can maybe say that it's less than 77%. We can maybe say that. All right, so the null hypothesis is that the probability is 77%. And we're thinking that the probability is less than 77%. Level of significance, 1%. And this is a left hand. Okay, because this is a probability, this is going to be a standard normal. All right, so P hat minus P divided by PQ divided by N Z-score, so I take that to 2 decimal places. I create my p-value right now. This is based upon a z of -265. Always look it up as a negative. It is negative, so that's good to go. So -265, 0040. We reject and accept. So that's really small. So left tail. So alpha is 1% in this case, and I have a p-value of 0040, so that's going to be smaller. So the distance from the edge is smaller. The p-value is 0040. So I see that the p-value is less than my alpha. That means I reject, it falls in that rejection zone, reject H0, accept H1. All right, so reminding myself what the heck this is. The H0 is that the probability is equal to 77%, and the alternate is that the probability is less than 77%. So we reject H0 and accept H1. We reject that the probability of a fatal accident is due to intoxication is equal to 77%. So we reject that the probability is equal to 77% and accept that the probability is less than 77%.